Hello, calculus students, Math 181. I'm starting chapter 5, and one of the topics in chapter 5 is an area problem. Classic problem, how to find areas of non-flat shapes. And we're going to be finding area under a parabola, for example. So if you look at this, we're looking at the parabola y equals x squared, and on the interval from 0 to 1 we want to know this area. And how do you calculate it? Because it's a curved area, it is not that simple, although we will find out that it is pretty simple, but it took a long time to develop. So there were all these estimation techniques historically, and one of them is to use rectangles. So we will approximate the area using n rectangles. And it says we will do 3 approximations using n equal 4 rectangles. One's called R4, one's called L4, and one's called M4. So the first one we're going to do is R4, and that's going to be 4 right rectangles. This means using the right endpoint on each subinterval. We are going to do that calculation now. L4 is left rectangles, and M4 is midpoint. So let's take a look at this. So I've drawn the curve, y equals x squared, from 0 to 1. And we're looking at them. I'm going to write this as r sub n to let you know that n equal 4 rectangles. You could do r sub 5, 6, whatever. Now delta x, a change in x, is equal to b minus a over n, and since this is a and this is b, we're looking at a change in x as 1 minus 0, so I took the 1 minus 0 over 4 as a quarter, so 1/4. This is going to be our rectangle width, and it's going to be our subinterval width. So what we are doing basically is taking from 0 to 1 and dividing it into 4 equal pieces, and when you do that you get a width of 1/4. So I mark this as 1/4, that's a delta x as 1/4, that one's a delta x, delta x, delta x, and we have 0 to 1/4, 1/4 to 1/2, 1/2 to 3/4, and 3/4 to 1. That's your delta x, and those are 4 subintervals from 0 to 1. And I wrote 0 to 1/4, 1/4 to 1/2, 1/2 to 3/4, and 3/4 to 1. And what we're going to do is choose for the right rectangles a right endpoint. Now the right endpoint here is the 4th. The right endpoint on this one is a 1/2. The right endpoint is 3/4 here and 1 here. Now what that means is we're going to use on this subinterval the right endpoint. We're going to go up from the right endpoint to the curve and draw a rectangle here. And the thing is, we'll be able to find the area of a rectangle. It's just length times width, and it's going to be a little bit more than the actual area because we're trying to find the area here, on the real area under the curve. And this is going to be an approximation. So what we're going to do on that subinterval, use the right endpoint to come up to the curve. And then we'll go on the second subinterval, use the right hand endpoint, come up to the curve, like that. And that will be our second rectangle. And these were the techniques used back in the day, and we all sort of do this development of area under a curve using rectangles. And the last one, I'll use the right hand endpoint to come up to the curve, come over, and now I have 4 what are called right rectangles. They're only right because they come up to the curve on the right part of each subinterval. Now the important thing is these rectangles, 4 of them, have a width of 1/4. So this is 1/4, this is 1/4, this is 1/4, this is 1/4, and this is 1/4. So they all have that width. And the height of the rectangle is as high as the right-hand endpoint. So the height of this one is f of 1. F of 1. The height of this one is, I'm sorry, it's f of 1/4. F of 1/4, I only saw that one. It's f of 1/4 is that one. The height of this one is the right one, so it's f of 1/2. The height of this one is the right-hand endpoint, f of 3/4. And the right-hand endpoint here will be f of 1. As a matter of fact, the height of this one is 1. And to find these values, you just plug it into the function, which is y = x squared. Now I'm going to call this first rectangle A1, and this one A2, and this one A3, and this one A4, and we're going to calculate those areas to estimate this, in your book is calling it an S, the area under this curve. So here we go. Area 1 is 1/4 times 1/16. So how did I get 1/16? Well, f of 1/4 is 1/4 squared is 1/16. So this is 1/16. F of 1/2 is 1/2 times 1/2 is a 1/4. 3/4, you get 9/16, and that one's going to be 1. So I'm just plugging the right-hand endpoint into the function. So my area 1 is going to be 1/4 times 1/16, which gives 1/64. Area 2 is 1/4 times 1/4. Area 3 is 1/4 times the 9/16, and area 4 is 1/4 times 1, which is 1/4. So I am going to get R4, is what the problem says to do. A1 plus A2 plus A3 plus A4, and I add those up, and I got 15/32, which is 0.46875. And this is an overestimate because you can see that there are more area, or there's more area in the rectangles than what's actually under the curve. All right, I'll be back to do left rectangles.